Alright, so in this video, I'm going to be talking about base excision repair. Um, Base excision repair is just another type of repair mechanism that our cells do when there's a damage in the DNA. In this video, I'm just going to try to go over like some few details, maybe just to help out understand how base excision works. Let's get started. So let's say this is our DNA, right? Let's say this is normal. And then suddenly let's say there's like a wrong sequence or a wrong base. Let's say this is the wrong base instead. Now, this wrong base will be recognized by an enzyme called DNA glycocylase. What DNA glycosylase like literally does is that if you have this base that doesn't really belong there, or like it's the wrong base, DNA glycosylase will literally remove it. The base itself. It could be the C, the T, or G, or A. It doesn't matter. But it will remove that base that was wrong. So, but here's the thing. It will only remove the base. But the phosphate backbone over here will remain. So, now let's say DNA glycosylase remove this base over here. Now, we will have this empty spot, right? It still has the phosphate backbone, but the base over here is now gone. Now, this site with the empty base is called an AP site. AP site. What AP stands for is just Abasic Phosphate Site. And just one way to remember this, Abasic literally means that it lacks a base. The A, like if you read this, Abasic, that literally means that it lacks a base. So you can read this like this site over here lacks a base on that phosphate site. That's why it's called an AP site. Now, because we have the AP site, there will be an enzyme that will recognize or will be alerted that there's something wrong on that site. There's no base. So that means an enzyme will be alerted, and then that enzyme is called AP, same thing as Abasic phosphate, endonuclease. So, AP endonuclease, what it will do instead, it will make a cut or it will cleave somewhere around here on the AP site. So once it cleaves, you will have this product over here, right? Like there's like now you have separated strand because it made a cleave over here. This AP endonuclease did it because it recognized that there was an AP site. So now you have this. Once you have this, another enzyme will be alerted again, and then that enzyme is called lyase. This part over here, this will alert an enzyme called lyase, and it's specifically like in your slides it was mentioned as drPase. You don't really need to remember that, but just to be specific. Now, once this lyase recognizes that there's a cleave on the phosphate backbone, it will literally like remove a stretch. Like it will remove this stretch of DNA over here, this stretch of DNA over here. It will remove it. So now you will have this product over here. Once you have this, you can make this like think of this like this is your new 3' end, and then this is your new 5' end over here. Remember, in DNA replication, DNA polymerase can only add on the 3' end. So in this part, Everything was done. Every type of enzyme was already called. The only thing that was missing is the DNA polymerase. Now we have DNA polymerase, right? So the DNA polymerase will come in and synthesize the strand. It will connect, it will start on the 3' end. So it will synthesize over that way, right? And then this will be your new 3' end. But it doesn't end there, because as you can see, there's this gap over here. Remember, like in DNA replication as well, there are things called lagging strands or Okazaki fragments. Treat this like an Okazaki fragment, because even though DNA polymerase already fixed or elongated the strand from the 3' end, we still have this gap between this 5' strand over here and this 3' strand over here. So if you remember, what's the enzyme that is responsible for sealing that gap? That enzyme is called lyase. Lyase. So let's say it was connected over here. Lyase will literally just come in and then seal that gap. So now you will have one continuous DNA strand over here. Lyase did that, and now you have a repaired DNA. Let me try to summarize what base excision repair is again. First, let's say DNA was damaged. There would be a wrong base somewhere around here. Now this wrong base will be recognized by DNA glycocylase and will remove specifically just that base, but not the phosphate backbone. Once the base is removed, it will create this site called AP site, or in long words, Abasic Phosphate Site. Abasic Phosphate Site literally just means it lacks a base on that phosphate backbone site over there. This AP site will alert another enzyme called AP endonuclease, and AP endonuclease will make a cleave, or will cleave this phosphate backbone over here. So now it will have this opening, right? This opening will now alert another enzyme, which is called lyase. Lyase will just remove a stretch of this DNA over here. So now you will have this like two separated strands. Now, once you have these two separated strands, DNA polymerase can come in and elongate from the 3' end of this strand over here, and then just elongate until it cannot anymore. Let me just complete that. So DNA polymerase can now elongate it, but remember, there will be a point over here that it will have to stop because it cannot elongate further. So to seal that gap over there, lyase has to come in to seal the gap within the phosphate backbone. Once it seals it, your DNA is now repaired. And that is base excision repair.